Welcome to the Group Shneiderman case study presentation, brought to you by Brian, Sean, Colleen, and Carl in the spring of 2014. The case study we will be presenting is called Biometric Rich Gestures, a Novel Approach to Authentication on Multi-Touch Devices by Napa Sebe, Kauser Ahmed, Catherine Isbister, and Nasir Miman at the NYU Polytechnic School of Engineering, published in 2012. In this case study, the authors presented a novel multi-touch gesture-based authentication technique. Their method combines biometric techniques with gestural input. A comprehensive set of 5-finger touch gestures compiled by the researchers were tested in a user study combining biometric data collection with usability questions. The researchers' objective was to exploit or use multi-touch technology to improve authentication on mobile computing devices, such as a tablet, compared to text-based passwords that are traditionally used. They were motivated by several things. The importance of security is increasing with wider array of user tasks being accomplished which contain confidential content such as banking. Conventional text-based passwords are weaker in a mobile environment, and typing on flash glass is 3 times slower than typing on a conventional keyboard. The Android pattern lock with connect the dots method lacks security because of low entropy, the tracing of finger oils, and shoulder surfing attacks. Their proposed solution was to combine biometrics and behavior with multi-touch capabilities, such as finger gestures, to create a unique and memorable authentication method. In doing this, the person's individual hand geometry would be coupled with dynamic gesture. Authentication would be based upon what you are versus what you know, and the person would employ palm movement along with the use of all 5 fingers, compared to existing 2-finger gesture libraries from iPhone 3G and GestureWorks. The research questions the authors wanted to explore included: is biometric data obtained from palm 5-fingered gestures sufficient and reliable enough to authenticate specific users? Would these gestures be an acceptable authentication method by the user? The researchers used a calculated equal error rate to incorporate false acceptance and false rejection. We will explore this later in the presentation. Would the gestures be an enjoyable authentication method? The researchers gauged emotional response by valence or pleasantness and arousal. And, of the 22 pro forma hand gestures the researchers used, what was the relative accuracy and satisfaction? What was the rating for user-defined hand gesture? The methods used by the researchers was qualitative. The independent variables included the 22 different multi-touch gestures that were created and evaluated by the researchers, and the dependent variables included the equal error rate and accuracy recorded. The researchers asked subjects to test any or all of the 22 gestures they were comfortable performing and asked for feedback on those gestures and for their thoughts on using multi-touch gestures for authentication in general. The researchers analyzed the biometric data using the equal error rate to measure accuracy, which calculates the rate at which false acceptance rate is equal to false rejection rate. They also analyzed the user experience by evaluation of the participants' answers about each gesture and how they felt about multi-touch authentication in general. The protocol took several aspects of gestures into account when designing their study. First, the palm movement, which explored static and dynamic palm position. Second, fingertip movement, including parallel, closed, open, or circular. Third, fingertip dynamics, such as full or partial fingertip. And finally, the total 22 gestures that used combinations from the set of gestural possibilities. Here is the list of the researchers' 22 gestures available to the participants in the user study. And here you can see 2 sets of gestures repeated from 2 different users, showing the slight inconsistency that needed to be taken into account. When collecting the data, the researchers evaluated the dissimilarity scores between the input gesture and the template on file. If it was lower than a threshold set, the input gesture was verified. They also calculated the equal error rate, mentioned earlier in the presentation, which compares the false acceptance rate to the false rejection rate. And they collected feedback from the user studies. A brief synopsis of the overall protocol used during this case study included creating an iPad app, developing multi-touch gestures, conducting a user study to test their 2 research questions to verify that the biometric data was sufficient and reliable enough to authenticate users and determined which of the 22 gestures were acceptable and enjoyable for users, and finally, analyzing the biometric data and user experience. The researchers found that the most promising gestures that optimized both authentication accuracy and user experience included close clockwise, counterclockwise, drag down close, fixed thumb parallel, fixed thumb close, fixed thumb clockwise, and fixed thumb counterclockwise. This is shown here when comparing the 2 graphs that will follow each other, indicating gesture accuracy and self-reported user experience. Here, the table shows the ranks of the static gesture and fingertip preferences of the users. The gestures that made use of all fingertips were rated highest. Participants liked fixed thumb rotation and did not like fixed pinky gestures. The researchers found that the gestures that users like the best were also the most biometrically secure. Ease of use and preference ratings correlated with those gestures that were most biometrically secure, and the more pleasant and easier the gesture, the more likely the user would perform the gesture accurately. From their findings, the researchers concluded that user preferences have a direct linear relationship to system performance, unlike with text-based authentication. Users rated the method highly and were open to adopting it for everyday use, and the method demonstrates the potential to improve multi-touch device authentication, user experience, and security. The case study raised several questions. It was unclear how they verified the gestures. Did they try having users imitate one another's gestures to see how secure it would be? Also, it seemed strange that only 6 out of 34 participants had ever used an iPad. The authors didn't discuss how users felt when they weren't verified using the gesture techniques either. And finally, in the user feedback, the majority mentioned that the gestures were easier and faster than text-based passwords. It might have been helpful for the researchers to do a comparison to actually see if the participants felt the same way when doing them both during the same time period. And here are our discussion questions. 1. What would be the likely outcome if a device manufacturer, Apple, Samsung, Google, employed an authentication exactly like the method described in this paper, and the researchers claimed it was their intellectual property and were deserving of compensation? 2. Can you think of any other multi-touch gestures that could be added to the set of 22 the researchers developed? Would it help increase security, such as avoiding shoulder surfing attacks? 3. What obstacles do you think might prevent gesture biometrics from being adopted as a widespread security technique, for example, for ATM authentication? And 4, if this study was extended to a small screen mobile smart device, how might this affect user gesture performance, and how might these user gesture adjustments affect the resulting error and forgery rates? Thank you very much for listening.